This is section 3.4, solving quadratics by graphing and taking the square roots. We're going to start with the warm-up. You should all be able to do this already, but if you can't, I'm going to get you started. Looking at it, we can see that this plus 1 will shift the graph negative 1, opposite of what we would think, and the plus 2 would shift it up 2. So we have a dot right here. Then this negative means it's going to be facing down, and the 2 means it'll be skinny. So something like that. But that's what we would do last quarter. This quarter we want to be more accurate. So you could plug some points into the equation and get the exact points, or we could use a calculator, which is what I want you to do. So get a calculator right now. Okay, remember you can reset your calculator by going second plus 7, 1, 2, and then doing it again, second plus 7, 2, 2. Now we're going to hit y equals, and we're going to type our equation in, negative 2, parenthesis, x plus 1, parenthesis, this button for the squared, plus 2. And if you hit graph, we can see the picture. That's what we have there. However, it's kind of hard to tell where it crosses all the lines, the x-axis and the y-axis. So here's something new. We're going to hit second, and above graph in blue is table, so we're going to access the table, and this is a list of all the points. So we can see that this graph goes through 0, 0, right here. So we're going to fix our graph. It also goes through negative 2, 0. Plug in a negative 2 into the equation and it spits out a 0. And you could do as many more as you want and get a slightly more accurate picture. You're going to want to do this when using Math Excel, because when it has you graph, you're going to want to put a point on the vertex and another point on another exact point from your table, or you won't get the correct graph. Now that we have this, you should be able to find the vertex. In this case, the vertex we said was at negative 1, 2. The axis symmetry, the x-intercepts, and the y-intercepts. I'm going to let you do that. Remember that this is the x-axis, so that's where the x-intercepts lie, and this is the y-axis. So wherever the graph crosses the y-axis is the y-intercept. I'm going to let you do the other 2 questions and all the other graphs, and in a few minutes we will return to the video. Please pause right now. Okay, welcome back. I hope you got your graphs done and your questions answered, but let's double check. The x-intercepts are when y equals 0, and they are at negative 2 and 0, 0. So you could write them as a point. We're just talking about the x's. Or you could say x equals negative 2, x equals 0. And then the y, where it crosses the y-axis, is also this point, but now we're talking about this part of it. We're talking about the y, this part, so you could say y is 0. Okay, here was the other graph. It had a vertex at 0, 0, axis symmetry at 0 because it got cut in half, x-intercept at x equals 0, and y-intercept at y equals 0. This very last one should look like this. Okay, vertex, negative 4, 3. Axis of symmetry at negative 4. It folds in half at negative 4. But the x-intercepts, notice, it never crosses the x-axis. There aren't any. Okay, so you just leave it blank. And then finally, the y-intercept, it looks like there aren't any. But this graph really goes on forever. And if it went up really high, it would eventually cross the y-axis at 35. Remember algebraically to find that, we could plug in 0 for x into our function machine, and it would end up spitting out 35. Now here's the new stuff. I'm asking, what are the solutions to the equation? Well, solutions to the equation are when y equals 0, in other words, when the graph crosses the x-axis, and we already found that when we found the x-intercepts, right? When it crosses this line. Our solutions are then negative 2 and 0, and those numbers can be graphed on a number line. We did that right here. So we call them real solutions. There were 2 real solutions. Going back to this next picture, you can see that it crosses the graph at one point, and that's when x equals 0. So our solution is x equals 0. There's one of them. So we have one real solution. And then lastly, if we look here, it doesn't ever touch. So because we had nothing right here, there are no real solutions. As a matter of fact, there are two imaginary solutions. We can imagine where they are, and I can use algebra to give you a number for them, but they don't appear in the real world, and I can't draw a picture for them. That brings us to the fundamental theorem of algebra, which says that the degree of a polynomial function is the same as the number of roots. So right here, remember, degree is the biggest exponent. This has a degree of 2, this has a degree of 2, and this has a degree of 2. So they should all have 2 solutions, or 2 roots. We should change this word roots here to solutions. Well, this one did. This one says 1, but really there's a duplicate. So there are 2, but they're both the number 0. And if that bothers you, don't worry about it. We'll talk about it later. And then this one had 2, but they weren't real. They were imaginary, because imaginary solutions come in pairs. Just follow along with this part. Don't worry, we'll talk about it later if you don't understand. So this one, remember, degree of a polynomial is the biggest exponent. So this one has a degree of 5, which means it has possible roots of 5, 4, 3, 2, or 1. Okay? And then it has possible number of imaginary roots. They come in pairs, so that's even numbers. 4, 2, or maybe 0. Copy this down, just let it sink in a little bit, and we will clarify later. This next page is all about the calculator. We can use the calculator to find the x-intercepts, which are the solutions. They're also called roots. So I'm going to let you take a look at this, but it walks you through everything that we've done, plus some more. And we're going to skip down here to using square roots to solve a quadratic equation. And it says, what are the solutions of 3x squared minus 75? So step number 1, it says to write the original equation. And so I've rewritten it right here. Again, when you do Math Excel, you need to do it in your notebook. Now we want to isolate the x squared on one side of the equation. So we are going to do the opposite of negative 75. We're going to add 75 to both sides. This is like the solving you did last year. So we have 3x squared. Negative 75 plus 75 goes to 0, and that equals 75. Now we want to get rid of 3 times x squared. So we're going to divide both sides by 3. And we have x squared. 75 divided by 3 is 25. So last year you'd be done, but this year we have a squared right here. So we have to figure out how to get rid of a square. To get rid of a square, you're going to take the square root of both sides, and the square root of 25 is 5. But I'm going to tell you right now, you're not done. When you, as a mathematician, decide to take the square root, you have to answer the question, give me every number times itself that'll equal 25. Well, the other number would be negative 5. So if you think about it, 5 times 5 equals 25, but so does negative 5 times negative 5. So again, if I just gave you a problem on a worksheet and said, what's the square root of, say, 16, you would say 4. But if you, as the mathematician, decide to square root to solve a problem, you have to find all of the answers. And in this case, mathematicians are lazy, so we often write it as plus or minus 5. Again, that just means positive 5 is an answer, and so is negative 5. If you were to graph this equation, that it'll cross at positive 5 and negative 5. Let's try 3. The first one, number 1, 3a squared minus 4a equals 71. Now we need to get rid of the 4, so we're going to add 4 to both sides. And that leaves us with 3a squared Negative 4 plus 4 cancel out, and we have 75. Now we want to divide both sides by 3. So a squared equals 25. Finally, to get rid of the square, we are going to take the square root. And just like we had last time, we have a equals 5 and negative 5. You could say plus or minus 5. And this would have two real solutions. If you graphed it, it would cross the line twice. Now let's look at number 3. We have 2x squared minus 3 equals 103. Step 1 would be to add 3 to both sides to get rid of this negative 3. And we've got the 2x squared, stays down here, plus 3 makes it go away, and we get 106, 103 plus 3. Now we need to get rid of the 2, so we're going to divide both sides by 2, and that'll give us x squared equals 53. Last step, we need to get rid of the squared. We're going to square root both sides. And the problem is if you put the square root of 53 into the calculator, you get a decimal. That decimal is 7.28 and a bunch of stuff. So we have two answers. We could say our x is equal to plus or minus, because we took the square root of 53. Or we could say x is approximately, and I'm going to round this, 7.3. Again, the 2 will turn into 3 because this 8 right here was 5 or bigger. And don't forget the plus or minus. So this also has two real solutions. They're just not as pretty as 5 and negative 5. They have a decimal. And lastly, for number 5, we're going to do one more. Okay, we need to get rid of the negative 8. So we're going to add 8 to both sides. If you do that, you get 4n squared equals negative 6. Now to get rid of the 4 times n squared, we're going to divide both sides by 4. Negative 6 divided by 4 turns into a decimal, and we get n squared equals negative 1.5. Square root both sides. Now I would like everybody to put the square root of negative 1.5 in their calculator, and I'm going to have the video paused for a moment. When you have that, discuss what you got with your neighbor. Your calculator should have said error, because you can't have a negative under a radical sign. There's no number times itself that would make a negative. So it's actually imaginary. So you can say no real solutions, or you could say n equals I, the square root of 1.5. Okay, the negative becomes an I. You're telling people this is just a fancy I, that it's an imaginary number. Now, you would have to be really careful on Math Excel because it won't let you have a decimal under the radical. This is actually kind of weird. You would leave it as a fraction. So I, the square root of 6 over 4. Even better, you'd want to simplify using the Math Frac button. And on Math Excel, if there's a fraction, you're going to want to leave it as a fraction. Use Math Frac. Okay, push the example button to see how they want their answers. And if it is an imaginary solution, you'd write no real solution instead. So for this problem, you could write no real solution, this answer, but you don't need to have the fractions. What I'd like you to do now is problems 2, 4, and 6. However, before you do that, I want to show you this back page. There's a bonus problem. And also, here's your homework. Okay, the 3.4 on Math Excel is mandatory. The yellow packet is extra credit. They're extra practice problems. The front of the yellow packet, the first assignment says 3.5. Change that to 3.4. You'd only have to do problems 1, 2, 4, and 6. If you choose not to do these, that's fine. If in your math lab, you may have to do them anyway. But if you don't do these and you want to retake the test, you'll have to get these done first. Thank you.